Hi, this is Albert from AWB Electrical and Maintenance Services. Just a quick little video on circuit breakers. So I've just got a couple examples of circuit breakers here. So these two guys are MCBs, miniaturized circuit breakers, designed to be DIN rail mounted on the back of a DIN rail there. And this guy here is a molded case circuit breaker. So this is normally a bit different mounting in that. So it's designed for a lot more higher current applications, normally like sub-feeds and so forth. And this one is designed that you can install a shunt device in here to trip based on different conditions. So when you buy these, they come bare like this. Then with a the shunt is bought separately. This one's actually broken, so it was actually replaced because the main switch on it broke off after a fault condition. So with regards to these, this breaker here gives a good example of what's inside these two guys, but this is pretty much on steroids. So these, because you have to put something inside here for the shunt, you can pull these apart, so forth, and then inside them, you can see the whole mechanism in there, so forth. So these guys here is basically the switch mechanism, and these here are your arc chutes. So what you have here, very different to what is a larger version of what you have in here. So there'll be a very, very small version of this inside these guys here. So this is what these are for, is when under a fault condition, when this trips and these arms come back, an arc will be formed, a spark or flash will come across as it breaks, and then as the lever, basically, as you can see the angles there too, it's in an arc, it's in a curve. As the arm comes through, it will flare the arc, and then these guys, these chutes will just cut through the arc, and the arc will basically lose energy as it opens up. So basically you'll lose a little bit there through each one, and then as it opens up, the arc will be basically broken in that. So that's very, very important, because these chutes and this gap this goes to dictates its fault current rating, which is different for AC and DC applications. So an example of that is here. You can see there on this here, under 240 volt, the fault current rating is 85,000, but under, it's a bit hard to see, there we go, under DC applications it's only 10,000 volts. So it's very, very different between there. That's because the way AC and DC operate, very, very different. And with these guys here, you've got to be very careful if you're using these in a DC application, that these are rated for DC operation. So to my knowledge, neither of these brands are rated for DC. They probably will work, but it doesn't necessarily mean that it's correct. And if a fault does happen, you may be in a spot of bother, and it may actually cause a fire. So I do know that Schneider in Australia, circuit breakers are rated for DC operation, and they do some dedicated DC circuit breakers. And normally a lot of the dedicated DC circuit breakers, they'll normally get you to in some applications, they'll get you to wire the incoming that way, then you'll loop it over here, then you'll come out there. So basically using the same breaker to break the one effective circuit, because what happens is when it goes through there, you got a next distance of X, and as you loop it back through, that's 2X. So you've doubled the breaking distance of the circuit breaker when it does that. So normally in DC, they'll have 2-pole and 4-pole applications for higher voltage applications, and each pair will do one polarity, positive, and the other one will do the negative. So it's common in solar applications when they use these, they'll have 4 poles. And they'll be looped through. So if you take anything away from this video, AC and DC totally different, and you're going to make sure that if you're using any of this switch gear for DC, it is rated for what you want to use it for. So that way, if it has a fault, it does what it's supposed to do and it trips under a fault condition. So if there's any questions, put them in the comments. Thanks.